In this video, I am going to tell you how we can solve this question number 23 from this book Engineering Circuit Analysis by Hayt Kemmerly. This question is on source transformation, and the question says that transform the dependent source in figure 5.67 to a voltage source, then calculate V0. Now before solving this, let me give you a quick revision of what is source transformation. Now, as per the source transformation simply says that we can transform any voltage source into current source and any current source into voltage source. How we can do it? Now, suppose if we have one battery in series with a resistance, this is R, this is Vs, then we can transform it to a current source. We can transform it to a current source in parallel with the resistance. In parallel with the resistance. This resistance value will be same as this one, right? Whereas this Is, the current, this will be related as Is is equals to Vs upon R, right? Or simply the relation between this Vs and this Is, the relation is simply Vs is equals to Is into R, right? So using this, we can convert any current source in parallel with the resistance to a voltage source in series with the resistance, or vice versa. And this is valid also for the dependent source. It means that suppose if I have some voltage source in series with a resistance, let this value of this voltage source, dependent voltage source, let this value be I, 2I, right? So this can be transformed into a dependent current source in parallel to the resistor having the same value as R, whereas this current source will be having the value following this rule. So over here, Vs is 2I, Is we need to determine, R is a resistance. So Is is equals to 2I upon R, right? So the value of this current source, it will be 2I upon R, right? So in this way, we can transform any voltage source into current source and any current source into voltage source. And also keep note one point that over here the polarity, like the current from this Vs, the current will be in upward direction because plus sign is at the top, right? So now the current, when we convert it into a current source, then as per this current that is coming out from Vs, the direction of the current source should also be in the upward direction. Means this direction and this direction of the current should align with each other. And similarly, if we are converting current source into the voltage source, over there, keep note that when we convert a current source into the voltage source, then the polarity of the voltage source should be such so that the current that is coming out from the voltage source should align with the direction of the current source, right? If you do opposite, then everything will get wrong. So this is source transformation. So now let me tell you how we can apply the source transformation in this question number 23 of this book, right? Over here, this particular branch, like it is open, so since it is open, so no current is going to flow over here. And what we need to determine, we need to determine this V0. Over here, this 2 ohm resistor, it is also disconnected, means no current is coming towards 2 ohm. So it means the voltage, if I just put the voltage across it will be 0 volt, right? So it means overall we have just, if I redraw this circuit, so it is simply (6 ohm), this is 0.7 volt, this is 12 V1. And what is V1? V1 is this, means the voltage across this 7 ohm. Right? Now, as per the question, we need to transform the dependent source. So, means transform means we are going to convert this current dependent source in parallel with the resistor. We are going to convert it into the dependent voltage source. And how we can convert? Simply by following the rule. So, now the current direction over here, it is downward. So I will put the polarity in this way so that the current is in this direction due to this dependent source. And this is 6 ohm. So I will put this 6 ohm over here. Right? Now remaining question, like this are the two terminals. Apart from this, like on the right side of this AB terminal, whatever we have, we will redraw as it is. So this minus plus 0.7 volt and this resistance of 7 ohm. This is plus minus V1, right? And this is, now what will be the value of this dependent voltage source? Now it will be, we will get this value from the formula Vs equals to Is into R. Now what is Is? Is is 12 V1. So 12 V1. And what is R? R is 6. So we get 72 V1. So our this value, it will be 72 V1. Right? And once we get this, now simply by applying the KVL in this loop, we will get the equation as 72 V1 plus 2 minus 72 V1 over here plus minus. So it will be 6I. Right? Now for this, the transition is from minus to plus. So it will be minus 0.7, and for this plus minus, so plus 7I equal to 0. Right? And what is V1? V1 is 7 into I. Substituting, solving this value means substituting the value of V1 in this equation, we will get 504 V1 I 504 I plus 6I minus 0.7 plus 7I equal to 0. Right? This we get 504 plus 6, 510, 510 plus 7. So 517I is equals to 0.7. So I we get as 7 divided by 5170 ampere. 5170 ampere. So now what is the question? Question is that we need to determine the V0. Right? This I, the current through this, the current through this, we get this I as 7 divided by 5170. Right? So our V1, it will be 7 into I, which is 49 upon 5170 volt. Right? So now what is V0? V0 is equals to V, this V, right, minus V. It is minus V. If we take plus over here, then it will be minus V plus V1. So minus V, it is 0, plus V1 is 49 upon 5170. So our V0 is equals to 49 upon 5170 volt. So this is the answer to this question number 23, that it is V0 is 49 upon 5170 volt. So if you have any doubt, you can put it in the comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.